Many students directly write 7 factorial for a ranging balloon. That answer is wrong, and today you will understand exactly why. The moment objects repeat, some arrangements look identical. Counting them separately causes overcounting. Objects: A, B. List all arrangements. AAB, ABA, BAA. Total equals 3, not 6. Why not 3 factorial? Because the two A's are indistinguishable. Step 1. Assume all objects distinct. For A1, A2, B. Number of arrangements. 3 factorial equals 6. Interchanging A1 and A2 does not create a new arrangement. For every distinct arrangement, it was counted 2 factorial times. So divide by 2 factorial. Division removes repeated counting, nothing else. In objects where P1 objects are identical of type 1, P2 objects identical of type 2. Treat all objects as distinct, in factorial. Each identical group creates overcounting. Every factorial in denominator represents indistinguishability. Letters B, A, L, O, N. Total letters equals 7. L repeated 2 times. O repeated 2 times. Answer: 7 factorial divided by. Total letters equals 11. M, 1, I, 4S, 4P, 2. Answer: 11 factorial divided by. Never write a denominator factorial unless you can say which objects are identical. Every division in PNC is because of indistinguishable objects or repeated counting of the same outcome. If you understand repetition, combinations become effortless. In episode 5, we'll break the myth: why circular arrangements are not in factorial, why fixing one object works when the formula fails. If repetition is clear, PNC becomes logical, not scary.